guys, welcome back to the shop. Frank here. I spent this morning cleaning up some of the loose ends from the last episode where I had just tack welded a couple of things. I went ahead and welded them off. This is my moving target plate rack array. So I'm building this for a local gun club. Similar to other plate racks, except that the targets on this plate rack can move or be made to move. There's a pendulum underneath the rack, which is released with by hitting a small target, and that pendulum causes the targets on top of the rack to move back and forth, oscillate. So I'll show you that in a second, the pendulum that is. I'm back on this project. I've got to start working on the actual targets which sit across the top of the plate, the rack. So there's there'll be 5 targets. So I've got some sheet of 1/4-inch steel up on the plasma table, and I'm getting ready to start cutting some parts out for this. So I'll show you real quick what the pendulum does, how the rack is supposed to operate, and I'll put a picture here of a standard plate rack. Now, you know, this gun club approached me and asked me if I could do this. They gave me a list of requirements. I've been working to that pretty much as best I can. Past couple episodes, we built the rack itself, and then the carriage, and then the pendulum assembly. So this is episode 4, working on the targets. We may wrap it up in this, so there may be one more episode to put the wheels and hitch and stuff on it so it can be moved around. So let me show you the pendulum, and then we'll go over the plasma table and cut some parts out. I'll make one target, make sure everything's working, and then we'll cut the parts out for the other 4 targets. All right, so this is the pendulum, pretty heavy. And the release mechanism. So you need a heavy pendulum in order to move the targets. This is all steel, so it weighs hundreds of pounds. So your first shot would be here. That releases the pendulum. As you can see, this carriage on top moves back and forth. And the amount of movement is controllable. There's 3 different positions for the linkage arm. It's right now in the mid position. So, okay, let's go cut some parts out, and we'll build the first target. There's room on here for 5, and then we'll, assuming that works out, we'll make the rest of them. So these other parts, I had previously cut them out. So I just have this as a spacer. Trying to guess the center of gravity, center of mass is a little challenging. Need to have the davit high in order to pick this up high enough to get it on the rack, but I want it low to give the greatest reach to put something on the table. that's better. So I have to be extra careful with this AR. This is AR 500. And it always rusts more than the mild steel. But I have to be especially careful with the plate dog on this because the steel is so hard that the teeth on the plate dog don't dig in and get as good a grip. The mild steel, they definitely grip. So it's not the best. So I just have to be extra careful. Of course, the magnet doesn't matter. Magnet don't care. All right. And put this down. By lowering the arm, I get more reach. Have to be prepared for this letting go at any moment. Just err on the safe side. Okay. Don't get anything under it. So this sheet weighs like 250 pounds, maybe 248, something like that, pretty close. Try to get the front edge here parallel with the table. All right, so for those of you that are considering a plasma table for your shop, I mean, handling material is certainly one of the things you need to deal with. If you're cutting signs, you know, it's thin material, 1/8 inch or less. I mean, even a piece of 1/8 inch 4x4 sheet of 1/8 inch is pretty heavy. You know, like 80 or 90 pounds, 80 pounds, 75, 80 pounds. I mean, if you're young and strong, that may not be any issue at all. As you get older, you know, you get weaker. And so anyway, material handling is something you need to deal with. And in a professional shop, big shops, they're going to have forklifts. Not going to be a problem. And probably, you know, could house a bigger table, 4x8 table or a 5x10 table. This is approximately, the cutting envelope of this is 4 feet by 3 feet approximately. This is a Langmuir Systems Crossfire Pro. I've had it for 3 or 4 years. I've been totally happy with it. They didn't give it, I paid my own money for it. They didn't give it to me. They don't know I have it. I mean, other than I'm a customer. I'm not shilling for it. There's other manufacturers out on the market, but this seemed like a good one. Fit my size parameters. A little bit bigger than there's smaller ones that are like 2 feet by 2 feet. I felt that was a little small. There are times when I wish I had longer, cut capability, but they've been few and far between. And in the cases where I've needed pieces longer than 4 feet, I've just cut 2 of them and welded them together. So, I mean, that's a solution. You can cut stuff longer than the table cut. It's 4 feet across and 3 feet back. There are ways to put a full sheet on here, like an 8-foot sheet, supported on the outboard end, and cut, move it, and keep cutting, and then move it and finish cutting. I've never done that. I've heard it can be done. Seems complicated, but if you needed to do it, it's possible that could be done. So, anyway, it's been a good table. I've had no issues with it. The electronics work, plug and play. I bought their torch, their plasma torch, the razor weld. Well, it's not Langmuir's torch, it's a razor weld, but it's built and sold with this machine. If you want it, you can buy Hypertherm or any other brand if you want. The razor weld's been fine for my use. It's limited to 45 amps. I have had 0 issues with it. It has worked from the get-go. So I got no complaints about it. It is plug and play, which is one of the reasons I chose it. You can't use just any plasma torch. If you have a plasma torch, there are ways to attach a hand torch to the Z-axis, but if you have a high-frequency start torch, it's not going to work on here. You have to have the pilot arc torches in order to use the table, because the torch starts before it touches the material. So anyway, it's been a good table. I've got no complaints about it, and I certainly have been using it quite a bit. All right, I got to get set up. I'm going to cut some targets, and we're going to get them on the rack. All right, I've spent the past couple of hours working on designs for the targets. I think they'll be interesting. Yeah, I think I just drained my table. Knocked the drain loose. That's all right. All right, so perhaps you can see a theme here. Got a locomotive, boxcar, tanker, boxcar, caboose. All right, I'm going to weld the collars on these 5 targets. Okay, so you can see the theme here. Got a locomotive, a boxcar, a tanker, a boxcar, and a caboose. And they're bigger than a normal plate rack target would be. I'll show you what. You know, this would be a typical plate rack target, but this would be stationary. So I've made them bigger on purpose, certainly wider on purpose, because they're moving back and forth. And the purpose is not to make it more difficult to hit the targets. You want the targets to be about as easy to hit as a stationary plate rack. But you want the little bit of intimidation factor because they're moving, but in reality, there's a center section the size of a normal plate rack target that never moves, right? It just shifts back and forth on this face. So as long as you shoot in the center, you'll still hit the target. So it's not to make it more difficult. It's to create an additional kind of an anxiety factor, right? Oh, it's moving, they'll be hard to hit, but in reality, they're no more difficult than, you know, a standard plate rack would be. So it's just for the fun of it, right? It's supposed to be fun. All right, now I think it's moving good. I can give it an additional distance, change that pin, but I think it's pretty good the way it is. Let's check our distances here. 14 inches center to center. 14. 14 and a half. 14 and a half. 14 and a half actually. Yeah, pretty close to 14 and a half everywhere. Okay, so I've got some more work to do to finish the targets. I need to weld the base plates down and need to make a stop. When they fall backwards, they need a stop so they don't go all the way down. And then I may need an adjustment screw here to control how far the target comes forward. It's leaning forward, which you want it to lean forward. The further it leans forward, the more force is necessary to knock it over, and you want the force to be pretty minimal. So I'll wind up drilling holes in these targets and putting bolts, adjustment bolts in. Good thing I got some carbide bits. I should have cut the holes with the plasma torch table. I might still do that. You guys, what are you doing outside? You raising cane? What are you barking at? What were you barking at out there, huh? What were you barking at out there? What were you barking at out there? Huh? I could hear you all the way from a mile away, I'm sure. Got to control them from barking it. It's even though we don't have any close neighbors, the sound carries here since it's so quiet. Yeah, okay. Good boys. I welded all these stops on so they stop the target travel so it doesn't hit the frame or anything. My data card filled up while I was doing that. So I got 4 welds, one at each corner of the target base plates. So it's secured to the frame. The only thing I have left to do is the adjustment bolt through the target. Potentially an optional thing, but you never know. You might want to have the ability to adjust the target so that its amount of lean is adjustable, because the more lean there is, the more effort it takes to knock it back. But I mean, it doesn't take much. But we'll put some adjustment bolts in here. I thought about trying to fixture these plates in the mill to drill them. I have carbide annular cutters for this mag drill, but this may work fine. We'll see how it goes. If I have trouble doing this, I'll just go back to the plasma table and that was no problem whatsoever. All right, folks, that's all the time I have for this episode. I'm going to come back next week and finish up a couple of things that need to be done still. I need the bullet deflector, go down the front here. I need to put the wheels on it. Also put a trailer coupler on it so I can use a trailer dolly to move it around. It's largely done at this point. I'll have to go around and make sure I got everything set. You know, I need safety nuts on the bolts that hold the targets on their brackets, so they're, you know, easily removable. I think everything else, I haven't welded the legs. I do need to weld the legs, just have them tacked, but I'll take care of that when I put the wheels on. I have to put an axle and a couple of wheels. So anyway, it's a good breaking point here. We'll come back next week, finishing up those last few items, and that'll be it. That'll wrap this up. May get some footage. I don't know if it'll be on the next episode, last episode, of setting it up at the gun range, and I'll get one of the people there to shoot it to show you, you know, how it works. Of course, that might demonetize my channel, so maybe I can't do that. Anyway, all right, we'll see what happens. So leave me a comment. Tell me what you think about my choice of targets. There are other targets. I will tell you this. I didn't make any video of it, but a year or so ago, I made several sets of train car shaped targets, much larger than this, about 24 by 24 inches, for the same gun club. So I've made, you know, a number of targets for them, so just hadn't gotten around to recording any of that for the channel. So anyway, that's where we are. Leave a comment and tell me what you think. We'll see you next week.